All right, so this next section is about the proportion of population, and it's very similar to the binomial distribution when we sort of had, only two possibilities, a success or a failure. So it actually uses very similar annotation and notation for this. So it should sort of not be new. I know reading it by yourself is always difficult, but basically the first thing that they need to check is that you know how to find your p hat, which is what they call that. And so this is going to be following that formula. It tells you what to do. It says that the p hat formula is going to be x over n. And so therefore, once you're done finding that, to find q, you just subtract it from 1 and just make sure it's written as a decimal as opposed to a percent. So letter A, we have both of the things we really need for this. We have the p hat is going to equal 40 over 80. And so if we use a calculator, that's going to give us 1/2 or 50%, so 0.5. So then that means that q hat is going to equal also 0.5 because 1 minus 0.5 is 0.5. So that is our answer for letter A. Letter B, same process. Our p hat is going to be 90 over 200. All right, 90 over 200. If you type in the calculator, it's going to give you 0.5. So if we subtract that from 1, we should get 0.55 for Q. We can even box this in if we want. All right, letter C, same process. 60 over 130. 60 over 130 should give you a score of 0.46, rounded at least. And then if you subtract that from 1, you should get 0.54. So now we have p hat and q hat. So pretty straightforward. If you have your x and your n, just put it as a fraction, find the decimal, subtract from 1 to get your p hat and your q hat. D is the a percent, and so really it's the work's already done for you. Whatever percent they give you, that's automatically going to be your p hat, and then you can easily find your q hat after that. 1 minus 0.25 is going to be 75 or 0.75. Letter E, same process. They give us the percent, which is automatically our p hat. 0.42 subtracted from 1 should give us an answer of 0.58. And so these are our answers for this. The nice thing about our proportion population is that it doesn't use the t scores, it uses our z scores like we've practiced. So those 3 that we memorized for the 90, 95, and 99%, those are going to be applicable in this case. So in this problem, it says a survey of 1,000 U.S. adults found that 33% of people said that they would get no work done on Cyber Monday since they would spend all day shopping online. Find the 95% confidence interval of the true proportion. So we can go ahead and start working on this. We can have our population or our n value, which is 1,000. All right, they went ahead and told us our 33% of people said they would not get work done. And since it's their percent, that means that that is our p hat, which is 0.33. Making our q hat 0.67. All right, and then finally we need to find our 95% interval, and we get to use our z sub alpha. So we should have that memorized as 1.96. And now that we have all of the pieces of information that we need, we can go ahead and plug it into the formula. And the formula for this is similar to what we had previously. P hat plus or minus our z score times, and this is where it becomes different, the square root of p hat times q hat over n. And we can plug all of these pieces in. Let's plug it in a different color. Let's try green. We have 0.33 plus or minus 1.96 times the square root of 0.33 times 0.67, all of that over 1,000. And when we plug this in, we can either write this as decimals or percent. It doesn't really matter which one you pick. If you pick decimals, then it would be 0.301 and 0.359, or you can change it into a percent by moving your decimal over 2 times and having 30.1% and 35.9% from bringing this over 2 times. And so this is our answer. All right, so hopefully that helps you when you're doing other problems like this. All right, and just like 7-1 where we used the information and we found our intervals, but then we took it a step further and found our population size, there's a formula for this proportion population as well. So let's read this question. It says, it is believed that 25% of U.S. homes have a direct satellite television receiver. How large of a sample is necessary to estimate the true population of homes that do within 95% confidence and with 3% points, within 3% points? All right, so let's go ahead and just write down some key information of this first. The first thing is we have our p hat, 25%. That is going to be 0.25. So therefore, our Q is going to be 0.75. All right, the other thing is we do have our 95%. So we can find our z-score to be 1.96. All right, and then the other thing that they tell us is that our margin of error, or E, is going to be within the word within is what you really want to watch out for, within 3% points. And I'm not really sure why they wrote it that way, but you can write it mathematically as 3%, obviously, which if you turn into a decimal is going to be 0.03. And so now that we have all of that, we can go ahead and plug it into our formula. Now our formula is n equals p hat times q hat times your z sub alpha over 2 over your margin of error squared. All right, so then we can plug in all that information. We'll use green again, and you should get 0.25 times 0.75 times 1.96 over 0.03 squared. And when you plug all of that in, it's going to give you 800.3 repeating. And since we're talking about the population, we're going to round up to the nearest whole number, which is going to be 801. Now, let's read that second half of the problem. It says, how large of a sample is necessary if nothing is known about the proportion? And you should have read it, but sometimes we gloss over things, and actually I didn't even notice this until later. But if you don't know anything about the problem, so basically you're not given this piece up here, then you are to assume that it is 50% for each one, just to make sure you don't make any mistakes, okay? So that's what we're going to do. We're going to assume what we don't know anything, so we are going to change our p hat and q hat to 0.5. And so really I'm just going to use the same formula as I did before, but now it's going to be 0.5 times 0.5 times 1.96 over 0.03 squared. And after I plug those new numbers in, I should get 1,067.1 repeating. And again, since we're talking about a sample size, we're going to round up to 1,068. And then that is our answer to this second half here.